ఏం చేయాలి?
అయితే ఒకసారి మీరు ఏం చేయండి అంటే మన స్టూడెంట్ సర్వీస్ బోర్డ్ ఎస్ఎస్బి ఉంటుంది కదా,
ఎస్.
ఎస్ఎస్బి.
ఎస్ సార్.
ఎస్ఎస్బికి వెళ్ళి ఒకసారి అక్కడ మనం రికమెండేషన్ ఒక లెటర్ ఇవ్వాలమ్మా.
ఎస్ సార్.
ఇస్తే వాళ్ళు దాన్ని మాడిఫై చేస్తారు. మీకు ఏమేమి ఉన్నాయి ఇప్పుడు ఎలక్టివ్ కోర్సెస్ ఏమున్నాయి రెండిట్లో? రెండు ఫస్ట్ ఈ సెకండ్
ఇది
ఏముంది?
మినరల్ ఎక్స్ప్లోరేషన్ ఒకటి, నెక్స్ట్ హైడ్రోజియాలజీ ఒకటి సార్. నేను
హైడ్రోజియాలజీ.
హైడ్రోజియాలజీ తీసుకున్నాను.
హైడ్రోజియాలజీ ఇప్పుడు లేదు అమ్మా. హైడ్రోజియాలజీ 6th సెమిస్టర్ ఎలక్టివ్.
అంటే ఇప్పుడు రెండు ఎలెక్టివ్స్ లేవా సార్? అంటే ఒకటే చేశారా దాన్ని?
ఒకటే ఒకటే అమ్మా. ఇప్పుడు మనకు హైడ్రోజియాలజీ, ఇంకొకటి జియోకెమిస్ట్రీ తో పాటు జియోకెమిస్ట్రీ ఓన్లీ. ఇప్పుడే మినరల్ ఎక్స్ప్లోరేషన్ ఒక ఎలక్టివ్ ఉంది మనకు. ఇది
అంటే
కాకుండా
ఇంకా వేరే బి ఎలెక్టివ్ తీసేశారా సార్ ఇప్పుడు?
బిఎల్ 5th సెమిస్టర్లో అయితే ఒకటే ఉంది. 6th సెమిస్టర్లో రెండు ఉంటాయి, హైడ్రోజియాలజీ అండ్ జియోకెమిస్ట్రీ.
ఎస్ సార్.
మరియు హైడ్రోజియాలజీ అయితే 6th సెమిస్టర్, 5th కాదు.
అంటే నార్మల్ గా వచ్చింది సార్ అలాగా. 5th సెమిస్టర్ లో కూడా 2 ఎలెక్టివ్స్ వచ్చాయి, ఏ అండ్ బి. అయితే నేను బి సెలెక్ట్ చేసుకుంటే ఓన్లీ ఏ చూపిస్తుంది సార్ ఎగ్జామ్ ఫీ కట్టేటప్పుడు.
ఏ అంటే మినరల్ ఎక్స్ప్లోరేషన్.
అంటే బి బి ఎలెక్టివ్ కోర్స్ కి క్లాసెస్ కూడా జరగట్లేదు కదా సార్?
అవును, అదే ఇప్పుడు ఎందుకు అంటే బి ఎలక్టివ్ కోర్సు అనేది అది మనకు నెక్స్ట్ సెమ్ లో యాడ్ అవుతున్నది. అది యాక్చువల్
ఈ సెమిస్టర్ లేదు ఆ కోర్స్.
లేదు లేదు, ఆ కోర్స్ లేదు. ఈ సెమిస్టర్ లో మనకు ఒకటే ఎలక్టివ్ కోర్స్,
ఓన్లీ వన్ ఎలెక్టివ్.
అంతే, మినరల్ ఎక్స్ప్లోరేషన్, దట్స్ ఇట్.
ఎస్ సార్. సో ఫీజ్ కట్టేయచ్చు ఎగ్జామ్ కి.
ఓకే, కట్టారా?
అంటే ఇంకా కట్టలేదు సార్, అదే డౌట్, మిమ్మల్ని అడిగి కడదామని.
అయితే మీరు ఏం చేయండి అంటే రేపు వెళ్ళండి అమ్మా.
ఎస్ సార్.
రేపు అడ్మినిస్ట్రేషన్కి వెళ్ళి ఎస్ఎస్పి స్టూడెంట్ సర్వీస్ బోర్డు ఉంటుంది.
ఎస్ సార్.
అక్కడ కలిస్తే వాళ్ళు
ఒకసారి వెరిఫై చేసుకొని అప్పుడు కట్టండి.
అంతే, వెరిఫై చేసుకున్న తర్వాత మీరు ఫీ కట్టండి.
ఎస్ సార్.
ఓకేనా?
ఎస్ సార్. థ్యాంక్ యూ సార్.
ఓకే. మరి నిన్న మన క్లాస్ అటెండ్ కాలేదమ్మా నిన్న?
అంటే యూట్యూబ్ లో చూసాను సార్.
ఓకే ఓకే. అయితే యాక్చువల్లీ నెట్వర్క్ ప్రాబ్లం వల్ల మధ్యాహ్నం స్టక్ అయిపోయి ప్రాబ్లం వస్తుంది అక్కడ. రెగ్యులర్ క్లాస్ అయితేనేమో డిఫరెంట్ గా ఉంటుంది.
అవును సార్, ఆన్లైన్ ఎంతైనా ఆన్లైన్.
ఇది ఎంత, ఐఎమ్ నాట్ సాటిస్ఫైడ్ విత్ దిస్ క్లాసెస్. ఓకే, లీవ్ ఇట్ బికాస్ ఆఫ్ ఇట్ ఈస్ అ లైవ్ క్లాస్ నా. Yeah, just we go on. Actually it is almost finished yesterday, but again just recalculate all the things just we discussed. Okay.
Yes sir.
Yeah. Yesterday we have seen what I shown you here. Yesterday I explained tonnage factor, how we like the tonnage, what it is called tonnage, and based on the collection of a sample, we'll do the reserve estimation. Reserve estimation means here how much mineral we are going to be extracted. That is, based on that, we'll calculate the estimation. Or reserve estimation, it is called actually. So, based on that, we'll do the again detailed sampling. After collection of sampling, we will do the ore reserve estimation calculation part. Suppose example for if you select that area, sample area, 2 hectares or 3 hectares. 2 hectares means 5 acres of a land, but the total area doesn't have a mineral deposit. Only some of the portion having the mineral deposit. But as per our requirement, what we will do and we'll consider the total area for a calculation purpose. So first of all, we have to collect the sample. How we will collect the sample? Here you see here geometric method. As per a geometric method, it's including the two categories. One, it is as a uniform spacing and a rectangular coordinates, and second one, it is a uniform spacing and 60 coordinates. So here the area, it should be divided. the area it should be divided, and in that area, if it is rectangular mode, So if it is a rectangular mode, we can divide that parts. Yeah, you see here the picture, it's explaining A1, B1, C1, and D1. And internally, these A1, B1, C1, D1, it's a outer portion of the sampling area. So the sampling area, what we are or where we are collecting the sampling, the area it should be divided into the grids. That means the specified and the uniform measurements will measure. We'll take the measurement uniformly. Suppose example for you see here from A to B distance, again it is divided into the 4 parts. And again A to C and B to D also you see. And finally C to D also you check it. It's a rectangular method, or sometimes we see it is as a squares also. The area it is divided into the 16 parts. From each 16 parts, we will collect the sample for 16 samples. 16 samples, we'll pick up the samples. So these are all the regular interval. That means what we are going to collect the sample, and that area we have to, please wait 1 minute. I have one more class, just I'll tell them. Yeah, the area, whatever we have selected, we have to first, the area it should be divided into the grid pattern. Grid pattern means, suppose example, how we will make the grids. Actually, in a reconnaissance survey, there are 2 types of surveys we have. One, it is a reconnaissance survey, and second one, it is a detailed survey. In a reconnaissance survey, the samples will be picked up in a ore deposit area. Randomly, we'll pick up. And then, as per that, we will calculate the anomalous zone, threshold values, background values, all those. Once we will get the result, and again we will do the analysis, and which area it has a highest anomalous zone. Just example for you see here, this is a ABCD of area what we have collected samples. This area first we have to pick up the sample from different locations, and we do the analysis, and as per analysis we'll get the result. Okay, now result, based on that result we find out which area it is a threshold having values, and which area it has a anomalous zones. What it is first of all threshold, and what it is background values. Suppose if you are searching for a uranium element, or if you are searching for a quartz deposit or a quartz mineral, this uranium or a quartz, it has some limit of a content. Quartz we can calculate in the percentage level, and the uranium we can calculate into the ppm level. So that what is happening here, the element uranium or a quartz, which are normally they will present in a earth crust in the unmineralized area. Suppose example for uranium 1 ppm in soil, it is a normal value in your soils. So, or else the same uranium element you see in a granitic terrain areas. In a granites, that means igneous rocks, if you see. In a igneous components, it has a 4 ppm. The limit it is a 4 ppm. So, in a reconnaissance survey, you have selected that area and you have analyzed, and you pick up the sample into the laboratory and you have done the analysis. Then you got the result above the, some values are having the above the 4 ppm areas. Just example for you see here A, B, between this is A, B, C, D, and we have located some points. These points may be, if it is having the high values, above the 4 ppm values. So the 4 ppm, it is a cutoff in a granitic terrain. So what is happening here? The 4 ppm, it is a normal background value here. Above the normal background value, we'll consider as a anomalous zone. And there are two words here, anomalous point and threshold point. The threshold point, it is average of all the samples. The average of all the samples will here. So that what is happening here? Above the 4 ppm values will consider. Oh, and we see the how many samples are having the above the 4 ppm. And that area, it's also we see that that's maybe in different trends, different trends. As per that, the trends will make a plan. We'll make it a plan. We check out a plan. The threshold value, it is indicating the upper normal background value. Suppose 20 samples here you have collected the 16 samples. From the 16 samples, 10 samples are showing the above the 4 ppm. Suppose 20, 30, 40 ppm like that. So the average we can take here. We'll consider and we'll calculate and we'll see the average value. As per that average value, we'll see the trend also here. The trend means direction of a dispersion of a mineral deposit, in which direction it is going to be dispersed. So as per that, the area we can make again into the grid patterns, because of why we should convert into the, or why we should into divide into the grid patterns means the grid areas, it is very easily to collect the sample from the deposited area. So example for you see here, it is a divide the area, it is divided into the grids A, B, C, D, it is divided into the grids. And we'll pick up the sample in the mid of a grid, in mid of a grid, so that the mid of a grid means what we are sample collecting from this is a grid. That is a representative. That's a representative. So in detailed survey of a sampling, what we will do the total samples we will collect very detailedly, and again we will do the analysis. Again we will do the analysis. So final, based on that the final result, and how much area we have divided the intervals. That's also must and should we have to calculate. Suppose example for 150 into 150 it is a mention, and the total area it is covered as a 1200 in 200 meters into 200 meters. So we can multiply that. So as per this, we can calculate the thickness of a value. Thickness of a value means the ore deposit of a thickness value. So this thickness value, it's also very important there. As per that, we will do the calculations. Then that is excluded, and the second one, it is included. Excluded or extended, both are the same. Included area method. In this case, what we will do here, the limited and the representative of samples are different here. But here we collect the samples, corner samples. That means corner samples means here this corner area. The corner area samples which are representative for the whole area. So that the sample we should collect the two corners from each of a grid. So we will get automatically 2 from this side and 2 from bottom side. So 4 samples we will get from 4 coordinates. And then again, the extent of area we can remove from here. Actually, the previously suppose we consider that area it is a 1200 into 1200, but here the extended area we will remove. That's maybe 150 around 300 from 1200 minus 300, the 900 square kilometer, the 900 meters square meters area we will get. So we'll consider that the 900 into 900, when we will get the weight percentage of mineral deposit we will get here it is in a included area. Again, some semi-irregular spacing or irregular spacing, and as per that, in irregular spacing means here we will do the reconnaissance. That means that area, once we will decide it, that area if it has a more and more mineral deposit, we will collect this sample with using of polygon method or triangular methods. So here the polygon method means like this. You see here, it's not like as a previously what we have seen grid. It is not a grid pattern. It is a randomly. It's a randomly we will collect it. But the space it should be maintained uniformly. The horizontal space it should be maintained uniformly. But vertical, when we go into the vertical, it is a different. But in previous case, it is not like that. It should be uniform maintained. So suppose if we wanted to collect every 1 meter one sample, so we will measure and we will pick up the sample for every meter, for every meter, for every meter, for every meter. So this is one case. And again, in a triangular method, the samples what we are collecting, it is midpoint. It is playing the very important role here. Based on this midpoint, we will collect the samples in all the directions, and we'll make a triangular between the 3 samples, between the 3 points, and between the 3 points, and we'll calculate the thickness of this area. Calculate thickness of this area, and we will get the weight of area. And next one, it is isocore maps. In an isocore maps, it's a look like as a contour line. I hope you have seen the contour line in a second semester maybe. So in a contour, what it is a contour line? The contour line, it is a line and it is a maintaining the equal distance from one point to the another point. Suppose example for, you see here 6 centimeter, it is 5 centimeter, 6 centimeter, 7 and 8 centimeter. This 5 centimeter, maybe it has a mineral deposit. And then uniformly it is maintaining the distance around the mineralization zone. Suppose if it is a mineralization zone, the area if it is having the 5 meters of a thickness, then again I am going to construct, or again I wanted to collect the sample around this area with maintaining of 1 meter. So this is a 5 meters, and then separately I am going to measure. So here it will come from 5 to 6, and it's maintaining the equal distance for each one. So that 5 to 6 and 6 to 7, 7 to 8. As per this vertical thickness, we are calling this is. So as per vertical thickness, we will find out the volume of a deposit. So here equal lines, contour lines means equally it's maintaining the line, and it's joining the equal points only. So that line it is called as a contour lines. Yeah, coming to the stratum contours. Yeah, they say stratum contours. Actually, it is horizontal to the bed. Particularly these type of stratum contours we can see in coal deposits. In a coal formations. Because of in a coal deposit, it is formed by the stratification. Stratification means layer by layer. The formations which are having the horizontally are parallel to the surface, and again these parallel lines which are maintaining equal distances. Suppose example, for if you are drilling the 100 meters for a coal deposit, but we didn't get it. So what to do? Again, we go to the 100 meters. 100 meters, the thickness we should maintain equally. 100 plus 100, 200 meters. It's a parallel to all the areas. It's a parallel to all the area. So as per this, we'll calculate the thickness, and it is multiplied by the thickness value. Maybe it is a 10 meters, or every 10 meters if you want to change, or every 30 meters. We should mention that. As per that, we will calculate. And one more, next one, it is a transverse sections. In a transverse sections, we prepare the data obtained from a number of boreholes. What it is a boreholes? Actually, in previous classes, we have seen the boreholes, drilling of a borehole method, different drillings. From that boreholes, we will collect the data. Maybe it is a core sample. Suppose if you can drill the 100 meters of a depth. If you can drill into the 100 meters of a depth, then we'll collect the sample from the depth of 100 meters. Okay, now we keep in a boxes, core storage boxes. Then again, the next area, and again, we'll drill the 200 meters. Now you compare with the from 100 to 200 meters. If you get any differentiation, just we check out once again. If you get differentiation, what are the differentiations we see? And again, the ore deposit, is it original or not? It's related to the primary mineralization or not? These are all we have to see here. And we'll do the calculation separately. Maybe it is a high grade deposit, low grade deposit, or medium grade. As for that, we'll calculate all this. Yeah. And again, there are some principles for mineral economics. We'll come into this one. Yes, the minerals, and what are the minerals are required, and what is the importance of them when we are going into the mineral. Yes, by virtue of origin, the minerals which are having the inherent distinct characteristics, and which distinguish them from natural resources, the most of important peculiarity is a non-renewable character. Like example for non-renewable characters means flora and fauna. These flora and fauna, we know that it's related to the biological. Once if it is finished, we cannot able to create. So that we see the situation, and as per that we will utilize. The millions of years it is taking the time for a geological process of mineral formation. Suppose example, for if you see the granite terrain, granitic formation. The granitic formation actually in a Kadapa basin, Archean granite, it has a life approximately, it is a 2,500 million years. Depend on their formations. Actually, the age of Earth, we know that. That's about 4,500 billion years. So, from starting onwards, that means when the Earth, it was formed, from that onwards, there are various types of minerals which were formed. And again, once the minerals, if it is a depleting stage, the mine, if it is out, then the deposit get exhausted without any chance of a replacement. There is no chance at all to replacement the thing. Suppose example for we are using for construction purpose of sand, but now sand it is very precious. Now it is all on extinction stage. It's in the last stage. So what we are doing, the builders which are using instead of that sand, they are using the robotic sand. These robotic sand will get the from crushers. We'll get from crushers, because why we are using that? This is a alternating and replacing. Alternating. We are using the alternating. So that is a reason. The main thing it is we cannot able to replace the minerals. That's one thing. Yeah, in localization part. In a localization part, whatever you see the mineral deposit, we are not evenly distributed in various parts of the earth. But a particular mineral deposit is highly localized in any region which in it occurs. For example, if you see the Canada produces 50% of the world's production nickel and comes from the single nickel producing area, that's Ontario. And the deposit it has almost 24 kilometers of a long and 32 kilometers of a wide. And not only that one, just you see the buried deposits in Andhra Pradesh. It's also very huge deposit in our world. It's also very huge deposit. And approximately it has a 50, around 50 kilometers of square kilometers of area it was occupied. You see how it was a very big deposit. So that here, what it is that the main it's a localization, the mineral deposit or the mineral formation, it's a depend on the local factors, and it is a limit till that area only. If you go into the international level, it's a logical consequences of localization. Naturally, occurring minerals are not confident to man-made political boundaries. In this process, no nation is self-sufficient in respect of mineral resources. Yeah, it's exactly, it's true. Even most industrially advanced countries like uh, America and Russia, not others. Again, we see the what it is a mineral deposit. It's having the more demand, and what it is having the more importance. As per that, we will do the produce and exhaustibility. The mineral wealth it is exhaustible. Once it is mined and consumed, it is lost forever. It's give the characteristics of a lifestyle, life cycle to a mine. That's a depend on the ore reserves, and it's some deposits maybe it's originally considered to be as a enormous size that's having in the process. Yeah, having the process their importance due to the depletion of reserves. For example, what I told you, buried deposits in Kadapa district of Andhra Pradesh, and it's yes, now it is also in exhausted stage. I mean, it's in ending stage of the mine. Again, we are ready to we are ready to produce, and again we are ready to find out the new mineral deposit. Yeah, so mining problems also we unpredictable. That's also we considered as unpredictable characters. What are those? Unlike that, industries, mineral industries involving the mining operation, it's a depend on the mode of occurrences of the mineral deposit. The mining may be open cast or underground. Mining has its own problems, and it has the unpredictable nature of mineral occurrences. Maybe it is a mineralization or a considerable variations in grade in a given deposit. Some uncertainties extend the persistence in a depth and increasing the cost of mining with increasing of depth. The cost, it is also playing a very important role, because of if it is above the surface, no problem to drill that one and to extract it. But once if you go into the deeper level, below ground level, then we will get the problems. So some safety measurements we need to take, and some precautions we need. But deeper mining, if beyond the 150 meters of depth, it's involving the temperature and the pressure effects also, 100%. Every 100 meters, if you go into the deeper level, the temperature, it is going to be increased 1 degree centigrade. So that is the reason that pressure and the temperature are also playing the very important role when we are going into the deeper level. So while if in the presence of a high temperature, it's a resulting the it's a burning, and it's increasing the rock pressure 100%, and it's a superimposed the load creates on the rock. These are the quite common deep in mines like polar gold mines, where the depth it is around the 3 kilometers of that one. So automatically we see not only that one, we see in the coal mines also, approximately they'll extract from the 3 to 4 kilometers of the depth. Now we can imagine. Now you can imagine. You see how what it is at temperature and the pressure, and how they are going to be working there. So for that purpose, once we are, if you wanted to open the mine, we have to follow the some rules, and we have to require some environmental matters, and environmental rules and the regulations we have to follow. The environmental regulations happen to be one more constraint to face in the mineral industry. The mining problems, including the different types of hazards we have, abnormal peculiarities of a temperature and pressure variation coupled with the rock bursts, free and gas hazards, collapse of a roof and side walls are encountered in mining industry. In recent strides in industrialization have brought new challenges to mankind. One of them is environmental pollution. That's a more important, and it's playing the more important role when we are doing the mining. Because of, if it is open cast mine, it's producing the huge amount of dust and a huge amount of air pollutants. It's released into the atmosphere, and then how we can control those all the things. So that some precautions we have to maintain. Suppose example, if you say the ground prospecting, development of mining, refining, and smelting on the environment, the volatile and emotional, but understandable when rational. One thing it is, yeah. Yeah, it's a one thing. It's a very obvious. The rules and the regulations must and should we have to follow the as per mineral industries. And while the Department of Environmental Regulations in USA, actually it is monitoring the all the aspects and all the situations. And the government of India, it's also following the central laws. The Water Prevention and Control of Pollution Act, it was introduced in 1974, and the Forest Conservation Act, it was introduced in 1980, and the Aid Protection, it was introduced in 1986. And MOEF, that's also Minister of Environment, Forest and the Climate Change, the notification issued by the Government of India in 2016, White Gazette number 166. As per that, we'll follow the rules and regulation once if you wanted to open the mine. And what are the impacts of a new discoveries and technological development? Yes, must and should we have to follow the new discoveries and technological development for sophisticated missionaries. When we are in manufacturing industries or accumulation of a stock or fluctuation in fluctuation in prices, and all those we are all keep in our mind, and we have to follow the some rules and regulation. And here given some examples, but actually it's a no need to us. And then minerals and the national economy. The achievement of a freedom in 1947, the Indian government has realized the crucial importance of minerals in a national economy and took steps for a planned mineral production and within the concurrent industrial expansion. So that here the creation of a Department of Planning and Development in the central government and establishment of several agencies concerned with the minerals have started a new chapter in our outlook for minerals. The country has again realized the national mineral policy. It was introduced for the planning of mineral exploration and mineral exploitation, and what it is the use. I mean, how we can utilize them as as per that they have developed the national mineral policy, and it was in the first 5-year plan. Those are the systematically this exploration should be done, and for a proper assessment of extent value of mineral deposits and systematic mining by the scientific methods and conservation of minerals without wastage and exploration for strategic minerals like sulfur, tungsten, tin, etc. and etc. The making of finished products from raw material or raw minerals and their export. The beneficiation of a low-grade ores by scientific research. Yes. Suppose sometimes what is happening, we'll get the low grade of ore deposits. The low grade of ore deposits, those are also playing a very important role and which are useful for to the research purpose. For the research purpose. And then if it is a high grade or a medium or a high grade deposit if we have, and those we will use for industrial purpose. So that's one thing. Yeah, substitution of deficient minerals by scientific research. And final one is collection of industrial mineral statistics through the Bureau of Mines. We have a one national organization that is called as the Indian Bureau of Mines. In the Indian Bureau of Mines, what is happening? They will give the permissions to us once we are going to start a mining. They will issue some rules and regulations, and as per that we have to follow. And this new approach has resulted the establishment of many new organizations like Indian Bureau of Mines. It was established in 1948, and Department of Atomic Energy, that is called as a DAE, and it is only the specification for atomic minerals like uranium, thorium, lead, radium, those for only radioactive mineral purpose. This department will work. And National Coal Development Corporation, and it was established in 1956, and it is working on only coal deposits, coal formations, and they will do the research and they will do the exploration on only coal but not other minerals. And one more, it is Oil and Natural Gas Commission. It was in 1956. It was in 1956, Oil and Natural Gas Commission, and it's searching for oils. Oils means like a petroleum, diesel, kerosene, and gases, CNG and LPG gases. These people, this organization, they will do the research and development, and they will collect the samples from different locations, and they will search for only oil and gas, natural oil and gas. And one more, it is a National Mineral Development Corporation. It was established in 1958. The National Mineral Development Policy, it is to search for minerals, to search for all the minerals except some strategic minerals. Those strategic minerals like uranium, thorium, and exception of that one, the other minerals like iron ore deposits, quartz deposits, or gold deposits also. The gold deposits also, they will search for this. And subsequently, we have a state trading corporation, and these will be working on the minerals and the metals trade corporation. And one more, it is a mineral exploration corporation, or that is called now, it is as a Mineral Exploration Corporation Limited, MECL. There are many national research laboratories we have, like National Metallurgical Laboratory and National Geophysical Research Institute, that is NGRI, and National Remote Sensing Agency, NRSA, Central Ground Water Board, that's for meant for only for water exploitation and exploration of water in different areas, and National Institute of Oceanography, NIO. In the NIO, oceans also having the mineral deposits like aragonite and calcite deposits we get from oceans maximum more and more compared on surface. So these all are which are useful for exploration of different minerals. And now, what about our present status? The present status of our Indian country, it's growing very fast. Now we know that the GDP of our Indian country, it has a 7.3 and above. Then previously it was actually like a 6.68 in 2017. But okay, that was about a 5 years old data it is. But now we have about the 7.8 we have. Yeah, the government of India in 1991 and 92, it's removed many restrictions on imports and exports through the liberalized exchange rate management system. Indian mineral industry, it contributes a sufficient amount to the national economy through the production of fuels, metallic and non-metallic, and including the minor minerals. As per Exim Policy 2002 and 2, and general awareness of the tariffs and trade, GATT it is called, we are calling that is as, which is a part of the World Trade Organization, WTO agreement which it has. Its imports can be controlled by only the through tariffs and the quantitative restrictions such as quotas, quotes, and licenses. The government of India has created the Department of Disinvestment in December 1999 to disinvestment to the public sector enterprises PSCs, Balco like Bharat Aluminium Company, which is the first mineral based industry was privatized by selling 51% of a share. It's a sterilite industries for 551.50 crores. And again, special economic zones were created for exporting and processing of different minerals, and export and import Bank of India, that was also it is useful for mineral trading. Yeah, what it is after completion of this collection of samples, now we do the processings. From this, there are various methods we follow the processing. Mineral processing before the mining, and mineral processing during the mining, and mineral processing after the mining. How we will do that, we see. The main object of mineral or ore dressing, it is broadly uh, to prepare the crude ore for more economical transportation and further processing, and to recover the metallic contents. Preparation by ore dressing includes the concentration of the valuable minerals within a smaller bulk than that of the original ore by removal of worthless constituents, or the removal constituents have a deleterious impact on processing. What's the importance of a mineral processing? Yeah, ore, we know that it's aggregation of different minerals, different important minerals, and it has a valuable metallic constituents. And once, if you extract it or mined, it should be profitable. It should be profitable. And the most of the rocks or rock deposits contain the metals or minerals. When they are concentration of valuable minerals, it's to justify for mining. So that before going to that mine, or before going to find out that ore deposit, what it is a ore deposit, whether how much area it is required for us, and how much mineral deposit we are going to be extracted, we will do the calculation to use of ore reserve estimation. Then only we come into the conclusion, and we will do the mining process. So first we have to collect the sample from different locations of that area, and we'll do the analysis, and we'll do the ore reserve estimation. And as per that of estimation, cost is also playing the very important role. The cost means, suppose if you now if you started that mining company with 50 crores of the amount, then your investment, it is a 50 crores, but what it is outcome, it must and should be above the 100 crores, then only it is a profitable, or otherwise we will get the loss. So those calculations are the must. Those calculations are must. We'll do the all the processes there. As per that, we'll go further steps. Yeah, there are methods. In a mineral processing begins before the mining, continues during the mining, and after mining also. The mineral processing includes a wide variety of methods. This is starting from the simple manual techniques, to highly sophisticated techniques. The mineral processing is broadly divided into the three categories. One, it is mineral processing before the mining. Second one, it is during the mining. And third one, it is a mineral processing after the mining. Yeah, before the mining, the mineral processing exercise is undertaken at the stage of exploration itself to understand the what it is the amenabilities of the ore for a mining and the processing. Testing on a laboratory and a pilot plant scales, it's a necessary for a proper exploration program. And mining feasibility studies we need to consider and we have to follow. Yeah, in before processing, we'll collect the bulk sampling from the different test pits or different test pits. Means we do the pits on ore deposit area for exploration purpose and for estimation purpose. How much area it has a ore deposit and what it is the depth. For that purpose, we'll do the drilling and collect the sample. And mineral processing, the mining processing takes place simultaneously certain types of mineral deposits. The mineral processing becomes an integral part in the mining method. Must and should it is a we can say definitely it is an integral part in a mining method. There are briefly described below here. Cutting of a blocks. Cutting of a blocks means here, particularly when you go into the stone industry like a granite, marble, limestone, sandstone. These blocks are it should be marketable in a standard diamonds. We need to follow the standard diamonds or standard methods, so that as per that standard methods will go. And once if you are going to the pitting on that area, or suppose in a pitting method, maybe if it is get any crack material, crack if you can identify on the surface, but it is not suitable for a blocks. It is not suitable. Must and should come, must and should the blocks, it's having the continuously formation and do not have any cracks and fractures on the surface. If it has a cracks and fractures on the surface, it is not suitable for a blocking. So here again, there are some processes given. Just we see the underground gasification of a coal. The underground gasification technique, it is applied for converting the coal seams into the combustible gas, and it's bringing to this gas to our surface for using heat of a power generation for industrial purpose. This coal seam is ignited and air is supplied to burn the coal. And halfway it is yielding a gas with a huge amount of carbon monoxide, hydrogen, and methane. The balance of heat gas it reaches the surface of a temperature maximum. It's having a 400 to 600 degrees centigrade. In this process, the mining gas equation are combined together. Yeah, after a mining process, the mineral process after the mining, treatment of ores gets the metallic concentration into useful to the products of a smaller bulk, and simultaneously to separate unwanted material. That's unwanted material means here gang material. In a ore deposit, whatever it is useful to us economically, it is called as a tenor. The unwanted material, because of the ore deposit, it's an association or a composition of unwanted or wanted material. Both will be there. Both will be combination. Both will be composite material. So that here, first we'll separate the unwanted material. unwanted material, and the remaining material it is called as a tenor. Then the treatment process is called as a mineral dressing. It's a two major operations in this process. One it is a accumulation, and second one it is a concentration. These two are playing the important role here. And one more thing, it is a mineral operation processing. It's a communication particle size. It should be reduction. And second one, it is a sizing. The separation of a particle depend on their sizes, and it's a screening or a classification we are calling. That is, in one more, it is a concentration by taking the advantage of physical surface chemical properties. Yeah, one more, it is dewatering. That means it's a separation of a liquid or separation of a solid particles. So these process we'll do here again. The combination, it's a particle size, it is going to be reduced, so that we'll do the crushing and grinding instruments. In the crushing and the grinding instrument, we the sample we put into the machines, and whatever size we required, and up to that we reduced. And we'll make the uniform sizes. Yeah, and second one, it is the sizing. Here the sizing, it is the screens which are useful, the classification of instrumentals which are useful for to classify the material. We will use the vibratory screens, or we'll use the multi-desk screens. We'll use the screens, those. Yeah. The concentration, one more. The concentration, it is we'll show the chemical and physical properties of a mineral or gang material. If it is the concentration, if it is an unwanted chemical composition of a material, it will be there. We can remove that one. We can remove the wastage. Wastage means here unwanted material. The unwanted material we remove from the original from original material. So yeah, these all the process we'll do in a mining mineral separation after the processing. And again, there are various processes there, and the classification of war minerals and strategy and critical minerals. Here, just we see the outlines. War supporting minerals. These war supporting minerals, we include that iron ore for iron, steel, and manganese for ferromagnesium, rao and tungsten, molybdenum, vanadium, titanium, nickel, antimony, magnesium, cadmium, zirconium, ore of aluminum, and copper, lead, and these all will be useful for different making of a different alloy metals. And beryl for beryllium oxide, and piezoelectrical quartz, germanium, sulfur, phosphorus, lithium, strontium, graphite, uranium, coal, and petroleum, constitute the which are called as war minerals. And in a strategic mineral, the strategic mineral again it's two types. It is a critical mineral. Second one, it is an essential mineral. So in a critical mineral country, it's a deficient supply in the position, but it is known as occurrence, such as they can be exploited. An essential mineral, it is one in which the resources are quite largely produced in sufficient quantities. Okay, I am stopping here. And we have our practical classes also. I hope after completion of this one, we have to attend the practical classes physically. At the time, we'll
సార్
detail.
ఎన్ని రోజులు ఉంటాయి సార్ ప్రాక్టికల్ క్లాసెస్?
ప్రాక్టికల్స్ 3 days ఉంటాయి ప్రాక్టికల్ ట్రైనింగ్ క్లాసెస్.
అంటే ఇప్పుడు మెయిన్ సబ్జెక్ట్ ఎలెక్టివ్ సబ్జెక్ట్ రెండు కలిపి 6 days సార్?
లేదమ్మా, మొత్తం కలిపి మనకు 3 days ఉంటాయి.
అంటే ఇది వరకు అంటే సెకండ్ ఇయర్ లాగానే?
అంతే అంతే.
ఎస్ సార్.
సేమ్ అంతే.
ఎప్పుడు ఉండొచ్చు సార్? అంటే ఏ మంత్ లో ఉండొచ్చు?
ఉంటాయి, నాకు తెలిసి ఈ మంత్ ఎండింగ్ వరకు డేట్ ఇస్తారు, 22, 23 అని అంటున్నాము. మరి అది ఇంకా కన్ఫర్మ్ కాదా లేదా అని తెలుస్తుంది.
ఎస్ సార్.
అప్పుడు చూద్దాం. ఓకేనా?
ఎస్ సార్.
ఓకే అమ్మా.
థ్యాంక్ యూ సార్.
యా, మోస్ట్ వెల్కమ్.